Good morning to one and all. Today's topic is differential calculus and subtopic is Maclaurin's series. Next question. Expand cos x into cos y in powers of x comma y up to the terms of fourth degree. So, whenever in the question they are asking up to the terms of fourth degree, then we want to find out partial derivatives up to fourth order. Here also we want to find out Maclaurin series expansion of cos x and cos y, because here you can observe in powers of x comma y. That means we want powers of x and powers of y. So compare x with x minus a, y with y minus b. X can be written as x minus 0, y can be written as y minus 0. So a is 0, b is 0. So we are going to substitute a as 0, b as 0. That's why this problem is under Maclaurin's expansion. The given function is f of x comma y equal to cos x into cos y. Find out f at 0, 0. That is cos 0 into cos 0. But we know the value of cos 0, that is 1. That's why f00 is 1. Next, we want to find out first order partial derivatives, that is fx. Fx means dou by dou x of f. Here we are doing with respect to x. That's why cos y is constant. Dou by dou x of remaining one is cos x. So we know the differentiation of cos, that is minus sin x. Fx value at 0, 0 is cos 0 into minus I am putting here sin 0. But we know the value of sin 0 is 0. 0 into anything? 0. That's why fx is 0. Next, fy. Fy means dou by dou y of f. So, our f is cos x into cos y. We are doing with respect to y. I am keeping cos x outside. The remaining one cos y inside the differentiation. So, cos x, cos y differentiation is minus sin y. So, fy at 0, 0 is 0 because sin 0 is 0. So, observe these steps. Sin 0 is 0. 0 into anything? 0. That's why fy is also 0. Next, we want to find out fxx. Fxx means dou by dou x of fx. We know the value of fx, that is minus sin x into cos y. Here we are doing with respect to y. That's why with respect to x, that's why minus cos y I am keeping outside. Inside the differentiation I am keeping sin x only. Sin x differentiation is cos x. So f(x) value is minus cos y into cos x. Now we are going to find out f(x) at 0, 0. That is minus cos 0 into cos 0. So minus 1 into 1 minus 1. So f double x value is minus 1. Next we are going to find out fxy. Fxy means dou by of fx. Dou by of fx we already know, that is minus sin x into cos y. Here we are doing with respect to y, that's why I am keeping minus sin x outside. So we have dou by of cos y only. But we know the value of differentiation of cos y, that is minus sin y. Minus into minus is plus. Sin x into sin y is the value of fxy. Now I am going to find out fxy value at 0, 0. That is sin 0 into sin 0. But sin 0 is 0. 0 into 0 is 0. That's why fxy is 0. Next we are going to find out fyy. Fyy means dou by of fy. We already know fy value, that is minus cos x into sin y. So we are doing with respect to y, that's why I am putting minus cos x outside, the remaining function inside the differentiation. Sin y differentiation is cos y. So f double y value is minus cos x into cos y. F double y at 0, 0 minus cos 0 into cos 0. But we know cos 0 is 1. That's why f double y is minus 1. Next we move to find out third order partial derivatives. F triple x equal to dou by dou x of fxx. The value of fxx is minus cos x into cos y. Here we are doing with respect to x, that's why minus cos y outside, inside only cos x. But we know the differentiation of cos x, that is minus sin x. Minus into minus is plus. That's why the value of f triple x is sin x into cos y. F triple x at 0, 0 is sin 0 into cos 0. That is 0 into 1 is 0 only. So f triple x value is 0. Next we are going to find out f double x y. Observe, f double x y means dou by of fxx. The value of fxx is minus cos y into cos x. Here we are doing with respect to y, that's why minus cos x outside, dou by of cos y. We know the differentiation of cos y, that is minus sin y. Minus into minus is plus, cos x into sin y. So f double xy value is cos x into sin y. Now we want to find out f double xy at 0, 0. That is cos 0 into sin 0. That is 1 into 0 is 0. So f double xy is also 0. Now we want to find out fx double y. Fx double y is dou by of fxy. Dou by of fxy means, here we can observe minus into minus plus, that's why sin x into sin y. Here we are doing with respect to y, that's why I am putting sin x outside. sin x into differentiation of sin y is cos y. So fx double y value is sin x into cos y. Now I am going to find out fx double y at 0, 0. That is sin 0 into cos 0. Sin 0 is 0, cos 0 is 1. That's why fx double y is also 0. Now we want to find out f triple y. So f triple y means partial differentiation of f double y with respect to y. Already we know the value of fyy, that is minus cos x into cos y. So minus cos x I am putting outside because we are doing partial differentiation with respect to y. But we know the differentiation of cos y, that is minus sin y. Minus into minus is plus. Therefore, the value of f triple y is cos x into sin y. Now I am going to find out f triple y at 0, 0. That is cos 0 into sin 0. That is 1 into 0 is 0. So, all third order partial derivatives are zeros. Now we are going to find out fourth order partial derivatives. F 4x equal to dou by dou x of f triple x. We know the value of f triple x, that is minus into minus plus cos y into sin x. So we are doing with respect to x, cos y outside because it is constant. Sin x differentiation is cos x. Now the value of f double x is cos y into cos x. Now I am going to find out this value at 0, 0. That is cos 0 into cos 0. So 1 into 1 is 0. No, 1. Because cos 0 is 1 only. Now we are going to find out f triple x into y. That is dou by dou y of f triple x. We know the triple x value, that is sin x into cos y, because minus into minus is plus. Here I am taking cos y outside. No, wait a minute. Sin x outside because we are doing with respect to y. Cos y differentiation is minus sin y. Finally, the value of f triple x y is minus sin x into sin y. Now I am going to find out f triple x y value at 0, 0. That is minus sin 0 into sin 0. Sin 0 is 0. That's why we are going to get 0. Next we are going to find out f double x double y. F double x double y is nothing but dou by dou y of f xxy. We know the value of f xxy, that is plus sin y into cos y. Here plus. Y means minus into minus is plus. Here I am taking cos x outside. Dou by dou y of sin y. So cos x outside. Sin y differentiation is cos y. The value of f double x double y is cos x into cos y. Now I am going to find out f double x double y value at 0, 0. So 1 into 1 is 1. That's why f double x y y is 1. Next we are going to find out fx triple y. Fx triple y is dou by dou y of fxyy. We know the value of fxyy, that is sin x into cos y. I am keeping sin x outside because we are doing with respect to y. So sin x into cos y differentiation is minus sin y. The value of fx triple y is minus sin x into sin y. Fx triple y at 0, 0 is minus sin 0 into sin 0. So 0 only because sin 0 is 0. Now I am going to find out f_y. This is nothing but dou by dou y of f triple y. We already have f triple y value, that is cos x into sin y. Here we are doing with respect to y. So cos x outside. Sin y differentiation is cos y. F_y value is cos x into cos y. Now I am going to find out this value at 0, 0. That means cos 0 into cos 0. We know the value of cos 0, that is 1. 1 into 1 is 1. Now all partial differentiation values we have. Now we are going to substitute in Maclaurin's series. Substitute these values in the expansion of f of x, y about 0, 0. Then observe how to write this one. This is the main important thing. I will explain. Please concentrate. Observe, f of 0, 0 is first term. Second term is 1 by 1 factorial. Here 1 factorial is there. That's why powers must be 1. Here 2 factorial is there. Power 2. Sum of these powers is 2. Y square. That means power is 2. 3 factorial is there. That's why 3. 2 plus 1 is 3. 1 plus 2 is 3. 3. Here 4 factorial. 4. 3 plus 1 4. 2 plus 2 4. 1 plus 3 4. This is 4. So here factorial is there. The sum of the powers must be same thing. And also you know the coefficients by using Pascal triangle. 1 2 1, 1 3 3, 1 1 4 6 4 1. Now we want to write down these fxx, fxy, fyy terms. Observe. So observe, if x square is there, we are going to write xx. If xy is there, xy. If y square is there, we write yy. Observe, in the first term, no y. In the next term, 1y. In the next term, 2 y's. That means y's are going on increasing. Here also observe, x cubed is there, that's why 3xx. Here x square y is there, double xy. xy square is there, xyy. Y cubed is there, fyy. Here no y, 1y, 2 y's, 3 y's. Here x power 4 is there, 4xx. X cubed y is there, so 3xy. X square y square, xxyy. xy cube, xy triple y. Y power 4, 4 y's. And also observe, no y, 1 y, 2 y's, 3 y's, 4 y's. Like this, you can remember this expansion. Now substitute all values because we get so many zeros. That's why after substituting all the values, we are going to get this as Maclaurin's expansion. Here we have minus sign. That's why I am taking minus as common. This is the final value of Maclaurin's expansion of cos x cos y. Next question. Expand e power ax into cos by in Taylor series up to second degree terms about the origin. Here they mention about the origin. That means a equal to 0, b equal to. The given function is f of x comma y is e power ax into cos by. Here up to second degree terms only. So we need second order partial derivatives. First of all, we want to find out the value of f at 0, 0. So f of 0, 0 is e power a into 0 cos b into 0. A power 0 is, e power 0 is 1, cos 0 is 1. So 1 into 1 is 1. That's why we are going to get 1. Next, I am going to do first order partial derivatives of f. That is fx. Fx means dou by dou x of f. Substitute the value of f. That is e power ax into cos by. Here we are doing with respect to x. That's why cos by is constant. I am putting cos by outside. Next, e power x differentiation is e power x only. That's why fx is e power x into cos by. That means here a is there, observe once. So e power ax differentiation is e power ax. Ax differentiation is a. So we are going to get a also. This is the value of fx. Now fx at 0, 0, that is a into e power 0 cos 0. E power 0, 1 cos 0, 1. 1 into a is a. That's why fx is 0. Observe, next we are going to find out fy. That means dou by dou y of f. Dou by dou y of f is e power ax into cos by. Here we are doing with respect to y. That's why e power ax is constant. E power ax into partial differentiation of cos by. That means minus sin by. By differentiation is b. Y differentiation is 1. Why I am putting b as this? Because it is a constant. Finally, fy is minus b e power ax into sin by. Now fy at 0, 0 minus b into e power 0 into sin 0. But we know the value of sin 0, that is 0. 0 into anything is 0. That's why fy is 0. Now I am going to find out f double x. F double x means dou by dou x of fx. We know the value of fx, that is a into e power x into cos by. So a constant. We are doing with respect to x. That's why cos by is constant. Remaining one is e power ax. E power ax differentiation is e power ax. Ax differentiation is a. So the value of fxx is a square e power ax cos by. F xx at 0, 0 is a square e power 0 cos 0. We know the value of cos 0, that is 1. E power 0 is 1. 1 into a square is a square. So f double x is a square. Next we are going to find out fxy. Fxy means dou by dou y of fx. Dou by dou y of fx value is a into e power ax into cos by. A constant, x constant. That's why e power ax is constant. Remaining one is cos by. We know the differentiation of cos, that is minus sin by. In by, be constant, for y 1. Therefore, fxy value is minus ab e power ax into sin by. Now, I am going to find out fxy at 0, 0, that is minus ab e power 0 sin 0. Why 0 means 0 into a 0, 0 into b 0. Sin 0 is 0, 0 into anything 0. That's why fxy at 0, 0 is 0. Now I am going to find out f_y, that is dou by dou y of fy. Fy value is minus b e power ax into sin by. Here we are doing with respect to y, that's why minus b into e power ax constant, sin by inside. We know the differentiation of sin, that is cos by. By differentiation is b into 1. Finally, minus b square e power ax into cos by is the value of fyy. Fyy at 0, 0 is minus b square e power 0 cos 0. Cos 0 is 1, e power 0 is 1, 1 into minus b square is minus b square. Now we have the values of all partial derivatives at origin. Now I am going to substitute all these values in Maclaurin's expansion. So this is the Maclaurin's expansion. Here also you can observe 1 factorial 1 power 1 x, y, no y, 1y. 2 factorial power sum is 2. Here x square is there, that's why 2xx. xy is there, that's why xy. Y square is there, that's why yy. Next you can observe no y, 1y, 2y's. This is the how to remember this expansion. After substituting all values, we get some values are 0. Substitute those values as 0. 0 into anything is 0. That's why after simplification, we are going to get this as Maclaurin's expansion of given function.